Net force in 2D, our second example, and in this case we're not solving for net force. If you read the example, we know that we have a net force of 0. So, oh, that's Charlie snoring. So I've got two tractors, and there's their forces, and I'm looking for force of friction. And this is it is a net force in 2D. I might have given you one like this in grade 11 actually. It's not that hard, it's pretty easy, but it's a different perspective on the question because we're not really looking at the up and down. We don't know the mass of these tractors. We don't know the mass of the rock. We don't know the mass of anything. So we're not looking at gravity. Just imagine what you're looking at with this free body diagram is you're in an airplane or a floating balloon, I guess, looking down at our tractors and our rock. So here's our rock. Here's the force of the first tractor, the second tractor, and I want to find the friction force. So because the net force is 0, then I know that the next net force in each direction must be 0. There's no net force in the x, there's no net force in the y. So when I solve it, this one's a little bit easy because there's no net force in the y, and we want to find friction, right? We want to find this one here. So we know the net force, it's like we're solving for something else. These are the same magnitudes, exact same angle from the horizontal. So the y component's going to cancel out, okay? So FK has no y component. And mathematically, I hope you can just see that by looking at it. If one of these was bigger than the other, or the angle was different, it would be a bit of a different story because finding that then this FK wouldn't be horizontal. That's all, right? FK would be on an angle somehow, and you'd have to solve for it. That'd be just another application of the same sort of thing. Anyway, so we do need to look at the x direction though to find FK. So you can see I called that the positive direction. We know net force is 0, so we're going to add the first, the second, and add the friction force, right? And so 0 equals the horizontal component of the first, the horizontal component of the second, and FK, and here's just sort of how I found them, okay? So you can solve for FK as negative that. Put it in as a number, and FK is 2.3 times 10 to the 4 newtons, or 2.3 times 10 to the 4 newtons west, which is just basically the sum of the two horizontal components of the other forces. Okay, I'll put a check mark on it. Looks good to me. It's of the same magnitude, right? Done.